Okay, well, hi everybody. Welcome to our 5th Data Science Education webinar. This webinar is being made available through the Concord Consortium, a nonprofit education technology laboratory based in Concord, Massachusetts and Emeryville, California. You can learn more at our website, concord.org/meetup. I'd like to introduce you to today's facilitator, Michelle Wilkerson of UC Berkeley. Michelle's work explores how youth learn with and about scientific computing tools such as simulations, data visualizations, and modeling environments. And her webinar will be about data moves and data stories that she has been using to explore and help support students in making sense of and making use of externally provided data sets. A recorded version of this webinar will be made available on YouTube. We're going to email you details about it through Eventbrite after the event. If you're comfortable sharing your name and face, please turn on your web camera during the webinar event so that we can see you. I'd also like to emphasize that the format of this webinar is participatory by design. This means that we will work together to decide the conversations, connections, and activities that we want to discuss. Bill will be facilitating the live questions that you have, and I will be the text-based questions on Zoom chat or on Google Docs. Michelle will explain what that means in just a few seconds. For those of you who are just joining us, welcome to our webinar. Our speaker is Michelle Wilkerson, who will be speaking about data science moves. Michelle, I'll let you take it from here.
Thank you. Thanks everyone for coming, especially right after Thanksgiving. I hope everyone had a good break. So I'm going to share my screen here, and inside of the presentation folder, you'll find my slides. There are a few live links in there that I will also chat to the box when we're using them. There we go. All right, and so I'm Michelle. I'm currently an assistant professor at the Graduate School of Education at UC Berkeley. I put a nice picture of Tolman Hall, which is famously the worst building on campus here. That's where I am. And so my plan for today, as Talia said, I really did design this to be participatory, and I'm happy to deviate from this plan at any time. It is heavily activity-based. So what I'm planning to do is start with a very short introduction of the research that I've been doing for the past 10 or so years around kids reasoning with data. And then sort of come up with an initial example of what makes data science different and interesting, or at least in my approach and my thinking about it, in contrast to what we might call traditional data analysis activities in the classroom. And then I want to spend most of our time doing some activities together. So we'll do one activity involving visualizing and exploring the California drought, and another activity investigating the effects of the reintroduction of wolves to Yellowstone. These are both activities that we've used with students and teachers. I know that I've got a rather advanced audience here, so you'll be doing some more advanced explorations than we typically do, but I think it'll be a lot of fun. And then, depending on where things go, I'm hoping to wrap up by talking a little more explicitly about these ideas of data moves and data stories that we've been using to organize our work with kids in classrooms. So first, I'll just talk a little bit about the research we've been doing around kids and data. This all started about, let's see, five to 7 years ago, when we started working with teachers who are interested in introducing kids to simple data analysis technologies in their classrooms. So my background is in educational technology. And teachers were interested in having students use things like Google spreadsheets or data visualization tools to explore data and find patterns that they thought were interesting. So we began working with middle school teachers around locally relevant data specifically. So here we have an example of, here's some work from a 5th grade class where students explored a rat infestation in their city. Here's an example from a 7th grade class where they looked at demographic data about their city. And this was mostly organized around creating visualizations that tell stories about data. More recently, we've been looking at kids using externally sourced data sets, so data from NASA, weather agencies, the United States Geological Society, to investigate scientific phenomena and to explore what kinds of supports are needed to do that well. We've also been looking at what teachers think about the integration of data into their classroom. So this is a professional learning session that we ran just this last summer, where teachers did activities very similar to the activities we're going to be doing today. And in 2016, we organized here at UC Berkeley, and this was in partnership with Tapan Parikh, Victor Lee, and Joseph Pullman, a short session about youth learning and data science education. So we invited about 40 people over to UC Berkeley to talk about their work in working with youth around data science issues, and really to identify some major themes and directions that the field should go. So all of these different threads of work that we've been working on in my lab over the last few years have informed what I'm going to talk about today. And I also just wanted to make a really quick pitch for the talks that came out of this NSF small workshop we held last year. So if anyone's interested in learning more about the conversations that went on at that session, there's a bit.ly link here to capital YDS talks. And these are all of the keynote presentations that people gave at that session. But for now, what I'm interested in is digging into what makes data science special and interesting when you do it in the classroom, and how can we support those interesting and special things and students' access to those interesting and special things. So I wanted to start with a quick example that shows what I care about. So to me, at least, what I care about when I think about data science. And often when people talk about data science education and why it's important, they talk about just these massive quantities of data, the importance and centrality of computers, and preparing a data literate workforce, and all of these kinds of issues, which I think are important. And I agree that they're important, but they're not really what drives my interest in data. What drives my interest in data science is how can data be used to answer questions students have? And how can data be used to answer the questions that students have that can't be otherwise easily answered? And so to illustrate what I mean by that and what it means for my approach to data science, I wanted to go through a typical data exploration and then re-envision what that exploration would look like through a data science lens. Before I do that, I just want to pause and see if anyone has any questions so far and scan the chat. Okay. So I wanted to start with what I might call a typical data exploration. This is extracted from the Handbook of Biological Statistics. This is an undergraduate level contextualized statistics course. And I want to look at one specific problem from that textbook. This was to introduce students to linear regression. And the motivation for this exploration was that the author said, a common observation in ecology is that species diversity decreases as you get further from the equator. And the author provided some data that might allow someone to explore this observation. So you'll notice there are locations here, the latitude of each location, and then the number of species observed in those locations. And the goal of the activity is to get people to look at this relationship between latitude and number of species. So here I've used on the right-hand side CODAP to plot latitude versus number of species. I'm curious if anyone thinks that this supports or does not support the observation that's noted here. What are people's thoughts?
It does provide support, but lots of questions arise too.
Mm-hmm.
Questions and complaints.
Some questions and some complaints. So I might go a little bit further, especially knowing that this is the regression chapter of the book, and try to fit this. So does that help anyone? Does that address questions?
It doesn't really address the questions, which are more about the provenance of the number of species.
Can you talk more about what you mean?
Just that somebody saying there are this many species at a given location is hard to imagine how that would have come about.
Mm-hmm.
Yeah, I think about, species in the ocean might be a lot more, like the differences between species might be smaller than like large land mammals. The difference between a bear and a deer is great. So I'm wondering about where they're collecting these too.
And so I could give a little more information about that. These are, this is data collected as part of the Christmas bird count conducted by the Audubon Society every year. So this data is from the year of the publication of the book, which offhand I think is around 2011. And it's a subset of bird species counted at these locations. Does that change anyone's interpretation or thoughts about the data here?
Well, in addition to other complaints, one might wonder then, from a statistics point of view, is there any possible relationship between, say, the efficiency of bird counters in Virginia versus Delaware? Because that could, you know.
The efficiency of bird counters could vary by latitude.
It could vary by latitude as well, exactly, right.
Which we could also use this to test, I suppose.
Right.
Okay, so I'll show you how the book treats this, and then I will echo some of your questions and concerns and see how a data science lens may help us explore those concerns. So the book does what I just did here using CodeApp, which is plot a fit line and calculate the fit line, and the book concludes the trend is in the expected direction, but is not quite significant. The equation of the regression line is number of species equals, blah, 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 I'm not gonna read that. Even if it were significant, I don't know what you would do with the equation. I suppose you could extrapolate and use it to predict that above the 49th parallel, there would be fewer than 0 bird species. Okay, so I actually like the way that the author treats this. They're skeptical, they sort of acknowledge the weaknesses in the analysis, they recontextualize the results really well. But as a person who's interested in birds, I had some questions too, questions that were not unlike the questions that Bill and Tim raised. I looked at these locations. So some are in Delaware, some are in Maryland, some are in Virginia. They're not very far away, certainly not distributed enough for me to think that we can make claims about latitude.
Right.
But I know a few other things about birds. So now I want to shift to thinking about what data science might give us for exploring this in a new way. I started by looking up some of these locations to get a better sense of what we're talking about here. And I noticed very quickly that searching for each of these cities yields a latitude or a longitude in addition to the latitude we already had. And so I used that to supplement the data set. So now I have the location, latitude, and number of species that were provided before through the Audubon Society, but I've also added this new column, which is longitude, which is my own data that I was able to access relatively quickly off of the internet. And then I started playing around with, what does this longitude help me to understand? Does it give me anything new? So first I just checked to see if maybe longitude has something to do with the number of species. It's not an observation anyone's made to me, but it seems to be just as good in terms of data. But then I did something else. So here we've got longitude versus latitude. I'll give you a couple seconds to think on that. It turns out that when you plot longitude versus latitude, you're creating a map. You're creating a map like this. So I took my newly constructed data set and uploaded it to this free online tool called GPS Visualizer. It took about a minute, and GPS Visualizer replotted my data points. So this isn't all that interesting yet, except that again, I know something about birds. For instance, I know that there are different kinds of birds by the coast. And so I started to wonder if I could predict the number of species better by looking at their closeness to the coast. And so here, what I've done is use, again, this GPS Visualizer tool to plot not only the position of these data points, but also the number of birds for each. Mm-hmm. And so you'll see we have big circles here at the coast versus smaller circles on the inside. And so that led me to wonder if I could more formally explore this. And so now we can do things like plot the number of species as compared to the distance to the coast, or a number of species as dependent on whether they're on the coast or not. So this is a whole new level of exploration that me, as someone who knows something about birds, thinks is more meaningful that I was able to do through sort of reconstructing and manipulating this data. And as Tim and Bill pointed out, we also don't know that much about how data were collected. It turns out they were collected through this Christmas bird survey. This is a 100-year-long citizen science project. It's one of the longest lasting citizen science projects in the world. So here's a picture from early days. It's still going on today. It's something that children participate in. So not only can we modify and make new sense of this data, but we can also participate in its collection. And so these three different factors are what I think is interesting about data science. So we've been calling them agency, tools, and access. So if we go through this sort of pattern of exploration with the data, I started by thinking, well, I know a bit about birds, and I don't think latitude's going to matter here, but something interesting might be going on. Maybe I should gather some more data that's, I think, more relevant to the phenomenon we're looking at and see where that gets me. I then realized that, so then I went out and found that data and merged it with the data that I had. And because I had access to new tools, because we have new tools for working with data, I could easily visualize that newly constructed data set. Visualizing that data set suggested a relationship that seemed more reasonable and more powerful than what came before. I could easily recategorize my data to explore that relationship more deeply. And if I wanted to, I could go even further with my inquiry by accessing the entire Christmas count data set. So we were working with a very small data set that was a reflection of a larger data set. And so these three dimensions are what I think is really interesting about data science, or what we might call data science perspectives toward investigations. And so if we think about what that means more generally for how we use data in classrooms, I think it leads to some questions we can ask. Questions around access. So where might data that's relevant for whatever exploration it is you want to do in a classroom, where can that be found? How might our questions change depending on the kind of data we have and the kind of data we might be able to access? What tools and formats are available for us to explore those data? And how might learners themselves contribute to or critique or have experiences that help them make sense of the data sets that we're working with? And how do those relationships affect how they make sense and meaning of the data? And so these three themes sort of lead to this overall overarching question and phenomenon that I'm interested in my work, which is there are new ways to access and manipulate data. And often we have these sort of interesting relationships with data. We might know a little bit about what's going on. We might have participated in some minor way in the construction of the data, but we're not constructing the data, and it's much bigger than us, and it's much bigger than we can necessarily think about. So we need to learn how to deal with these data and make them our own, reconstruct them in interesting ways. So I want to do a couple of activities today to explore these sort of ways in which we might think about and make data our own. And I'm going to start with a little activity about the California drought. But before we do that, I'm going to pause again and see if there are any questions.
Are resources for the upcoming activities?
The resources for the upcoming activities are available via link here. I'll put this here, and I'll also just chat all of the resources as they become needed.
Okay, there we go. I see the link. Thanks.
I think I can also, I'll put them in the document here. Oh, no, I can't.
So when you say, what do you mean by we're not constructing the data?
So I didn't go out and collect the number of species.
So that's all, just they're data that somebody else put together.
Yes, yeah.
Michelle, how do you think about statistical concepts that people have or don't have in terms of your three categories there? They're part of my agency and...
The way that I think about those, especially around agency, just because I've been thinking about this more specifically lately, is that I think that they affect how you think about, for instance, error and chance and measurement. So if I know a lot about bird watching, that might influence what I think the reliability of the data that I'm looking at, for example. A
Well,
lot of,
certainly also, I would think, greatly influences the kind of questions that you ask. The critiques that we just heard came from some, I don't know exactly what statistical concepts were in there, but I can easily imagine how those influence both what you ask and then
So that's what I was trying to say. So
Maybe concepts of bias or even model assumptions. The model wasn't a good model given the phenomena.
Mhm.
Or
Yeah,
the data
and-
wasn't a good. Yeah, sorry.
That's okay. I was just going to, and another example on the access side might be that if I don't trust these data, I can go out and look and see if there's another data set available that I can use to triangulate or challenge the data that I have available. One interesting thing, and something that I've been struggling with in thinking about this, is that a lot of the statistics education research is around repeated samples in the same moment of time, for instance. And most of these kinds of data sets are not constructed that way. Most of these kinds of data sets involve, for instance, repeated samples over multiple time periods across different geographies. And so thinking about error and the meaning of mean and variability in those contexts is very different. And so we're still trying to think through those kinds of questions. And that might become more apparent in these activities too, I think, because we're working with those kinds of data sets here too. Okay, so what I'm going to do is start us off not with a data set, but with a visualization. And I'm texting it to the chat window, and I'll also pull it out here. Here it is. So when you go to this link, the page should look something like this. This is a visualization built by the US Geological Society Survey, yeah. And if you just start to scroll down a little bit, like I'm doing here, you'll notice that it sort of clicks and zooms into California, and a lot starts happening. A lot. You might have to adjust, zoom in and out on the screen so that it fits. So this is a publicly available data set that the USGS suggests you use with students as young as 5th grade. There's clearly a lot going on. And so what I'll ask everyone to do is just take a look at this, scroll through, ignore the stuff that comes after this, just focus on this interactive map and bar chart for now. And let me know as you work through this, what are some things you notice? Feel free to chat it to the window or just say it out loud.
Ooh.
There we go.
Okay, so it's going down. July 2013, going down. Well, it's interesting that you can see some of the seasonal variability that we might expect, because trying to echo your bird statement, we know something about rain in California and when it happens.
Whoa.
Though there are some surprises.
It's interesting to see the classification for extreme drought expand dramatically in January of 2014.
Mm-hmm.
Yeah, the end of 2014 did not go well.
Sorted by
Past, future, August.
It's interesting to watch the time delay between the reservoirs and the drought, which sometimes is as expected, sometimes not.
So you might see the reservoirs increasing even though drought is being called across.
Right. It's sort of notice that there's some kind of time delay in both directions between the changes, and when they're not always obvious.
I do want a connection between the bar chart and the map.
That would be useful.
I want to click on the dots on the map and see the bar, corresponding bar light up. But
do you have is there a certain thing you're looking for that would be helpful to?
Well, so for example, if I'm looking at, well, the presenting thing was, it says California reservoirs sorted by elevation.
Right.
So I want to know, what's the highest reservoir? Where is it? You know, so I can try to click on it, and of course it's too small. So what's the highest big reservoir? And I can't tell which one it is, or even which direction the axis is going. I presume that the higher elevation ones are on the right, but.
It's
Right,
nice.
and as soon as you mentioned that question, it became like things flip in your mind, right? And I became acutely aware of the fact that there were choices being made for me. There are things I can't choose. I've got a one-dimensional choice, which is scrolling up or down.
And I think one of the things that we're finding and arguing is that those choices, anytime you're working with any data set or visualization, those choices are made for you.
Right.
And they might not be aligned with what it is you want to do. Okay. Oh. So my second question, now that hopefully people have sort of gotten a sense of some interesting stuff going on, I've spent hours with this and still notice new things. My second question is, what questions do you have? And so we already heard a few from Tim and others, but what are questions you have about what's going on here?
By the way, I'm amazed at how quickly some of you can wrap your head around some of this.
Don't mistake the existence of a question for the existence of interpretation.
That's right. Yeah.
I mean, I quickly look at these things before I even read what they're telling me. I'm going, what in the hell is going on with the width of the bars? And just this combination of trying to make sense without reading a bunch of stuff because there's too much to read. It's quite a flood of information. What about drought?
And we've used this with students in classrooms, and we take a whole day just talking about what's going on here. What do these things mean? Why are they put this way on the screen? What might they be hiding?
That sorted by elevation. Well, sorted, no hint as to which way they sort.
Right.
Yeah.
So,
well, and is the width representative of elevation change? Is this sort of elevation and volume on that x-axis in some way?
And then I discover the scrolling that's working on time, but when I first see it, I don't know what it is that's changing. That's not apparent. It was covered up somehow in my browser, so I couldn't see the time. I mean, it's just, so I'm still just exploring the visualizations, really.
And I've become focused on an oddity. There's one incredibly narrow bar about the way to the right.
Dividing line, but it's not, is it?
It doesn't change at all.
Yep.
Two of them.
And I can't get a name as I hover over it. So, oh yes, I did. New Exchequer Lake McClure.
What, really?
Oh yeah, I see it.
So my question is, why isn't that one changing? And I think that's typical of, as you're getting to know a data set, the things that appear out of sync or different than the rest draw your attention.
And this is another case where I would expect that your knowledge of the domain is driving that. It doesn't make sense that this would stay the same.
Yes, because reservoirs should be going up and down like the others are.
And usually aren't at 105% capacity either.
The thing that I noticed that a while before too, Bill, funny that you and I should know. It made me start to think, are any of these reservoirs connected in some way? So for example, like there's a pond system right near my house. There's an upper and a lower pond. And the upper pond is always at capacity. And the lower pond goes up and down with the weather and the rain, precipitation rate. So I started thinking, are some of these things connected? How does elevation relate to both rainfall and then, groundwater? Which direction is the water flowing in these various watersheds? Those were all the questions that occurred to me as I was trying to figure out what was going on here. It definitely seemed very odd. Not very odd, but I was surprised when I scrolled for a while and saw no colors, and then suddenly colors appeared. And I didn't see instantly dramatic changes in the reservoirs. Like I expected, I've got some very dramatic changes going on in my abnormal, dry, extreme drought kind of thing. But it wasn't synced up with my reservoirs in the way that I thought it might be. But I didn't get a good sense of the time scale and the way that it's designed with the scrolling here.
That sounds a little bit like what Chad was talking about earlier, where the ups and downs of the reservoir don't necessarily correspond to so here we have, I'm looking at September 23rd to 30th. The reservoirs are all going down, but there's a removal of some of the drought conditions.
Right, and I imagine there's some overlap between the seasonality of rainfall and the drought. So it's still drought for April, but it's still, more rain than you would get in some other months or something like that.
Yeah.
Yeah, I guess that would be a question about what classification, what the drought classifications mean. Are they relative to some average or based on a fixed absolute standard?
Or are they based on models where even if it's raining in April, it's raining less than we would expect, and so we just assume.
Yeah, that was what I was imagining for the relative to expectations.
And presumably the drought designation also would take snowpack into effect in the wintertime, and we don't see that. We only see the reservoirs.
Okay, so I'm hearing some questions emerging. And so now my questions are, what data would you need to investigate those questions? And how would you collect and organize that data? So some of the questions are pretty straightforward. I think one was, what's going on with this one reservoir? But I'm wondering if we can choose two or three questions people have and think through.
Well, I was holding back a question, but I'll put it out now. What's the relationship between elevation and the pattern of going up and down?
Right, Dan kind of suggested something about that. One might wonder whether lower reservoirs were delayed, say, relative to upper reservoirs.
And similarly for capacity, how does capacity influence the pattern of change? These are hard questions, though.
I told you I was doing advanced stuff.
Yeah, there's a lot of interesting first derivative stuff going on. I've just been scrolling back and forth watching two, Trinity Lake and New Bullard's Bar, the two widest in the far quarter, the right-hand quarter, and watching them almost move up and down with one another, but not quite. And, you know, so they're sort of 75% in sync, and then at other times not, which is making me ask, what are the driving forces about, you know, the change in percentage of capacity, and how would those affect, you know, reservoirs globally, and what kinds of local effects make that change happen differently?
Well, I notice there's a middle bar that never gets to 100% ever.
I think that's the same bar that other people were having trouble with.
Yeah.
Yeah, but I think it appears at different locations depending on.
You mean the super skinny one, Sherry, or you can hover over them?
It's the thick one that's.
You can hover over and get names. We have discovered.
Let's see.
Shasta Dam.
I'm having Oroville Dam.
Oh,
Whoops. Might be a
Oroville
delay
goes
there.
up and down.
Yeah, there we go.
Yeah, Oroville. Okay.
Yeah.
You're just saying it never gets to 100%.
Yeah, it never gets to 100.
Mm-hmm.
And then maybe because I'm in Northern California, but you know that people in Southern California are really bad about conserving water, and they're really good at watering their cement and or getting water from other places. And so I am curious about, it raises questions for me of, is the water being used in the reservoir just for, you know, are we getting water from other places, not just a reflection of the watershed, especially in Northern California versus Southern, because the drought seems to appear just in the Southern. It starts to spread. There's maybe one year where drought is determined across the whole state. But then you notice that the drought kind of starts, you know, all the exceptional drought areas start in the Southern California and then work their way up. But you get all the water sources in the northern parts of the state.
Yeah, it looks like it starts right there at Bakersfield.
Yeah. Yeah, there's something about the geographic region, like maybe you could calculate the area of the different colors and see if there's a relationship between that and maybe the delay of the water.
It also seems like, you know, we talked about the input. You're starting to talk about the output some, but, you know, primarily we've been focusing on input. So, you know, one reservoir might serve a huge number of people. Another one might serve far fewer. I was even wondering, it probably isn't a huge effect, but I was wondering about the geometry of the reservoir itself. Is it, it's like deep and not much surface area, does it make a huge difference in it being able to retain in these hot, dry times or not?
I do know that in Los Angeles, they put a bunch of little floating balloons over some of the reservoirs to prevent them from evaporating as quickly. That suggests it's not trivial.
Yeah, so I think a lot of these questions are circling around the meta question of what exactly affects reservoir volume. You know, what are the factors that affect reservoir volume? Because there's an implication by the proximity of these on the scrolling visualization that drought and reservoir volume are associated, but you know, there are lots and lots and lots of other variables we've just been talking about here that may or may not be associated entirely with drought conditions.
All right. So you'll notice that there's a get the data button here.
Yeah.
And
that's where we found snow data.
Now that you've thought a little bit about the questions that you have and what you might need to investigate those questions, we're going to show you the data they provide. So here's a bit.ly link. And this is going to open up, it's going to be a little slow, but it's going to open up a Kodak document with all of the publicly available reservoir data that we just visualized. There's a lot going on here.
Whoa, cool. Good job.
This is special thanks to Jonathan Sando, who helped us get this.
Did you put that link somewhere?
It's in her
Oh yeah, I see it.
slide deck.
It's also in the chat window for anyone who needs it.
Okay, cool.
So again, I planned this for the advanced level investigation. But I heard a couple of questions that I think could be addressed with some work using this data set. One involved the relationship between elevation and pattern of sort of changes in volume. One involved capacity and how that might relate to patterns of filling and depleting. One involved regional differences. And so I'm going to give everyone just a few minutes to take a look and see what questions they had that can and can't be answered by this particular data set.
I'm appreciating the magic poofs that come when you make a graph, as it has to cycle through its magic animation multiple times.
Which city is the dark purple at the very top?
This right here?
Is that Shasta?
Yeah, so this is Shasta Dam.
Mm-hmm.
And if you click on it, let's see if we can go down here.
Oh, there we go. Yeah.
Yeah, it will highlight it, and then you can click on it in the data table, and it'll highlight it in the map here for you as well.
Great.
So I'm going to give everyone 3 more minutes to just sort of acclimate. Okay, and we've got Frida sharing some of her results here.
Where did you share them?
She's in the shared session document. I just sent the link.
Sorry, it took me a minute to unmute there. I put them in the Google Doc that is the second link in the chat. Cool. Just to address the elevation question, and it was my guess, but I didn't realize how exclusively correct it would be that the higher reservoirs are much smaller.
Mm-hmm.
Okay. And so yes, what I was anticipating is that this would be a lot of data and it would take people a while to sort of find their bearings. And I wanted to reflect a little bit before we start digging in on how might the questions you had have changed now that you know the data you have access to.
I started trying to calculate some index of deviation from mean capacity or something like that to see if there were things like if it's a, does the size of it affect the size of the fluctuations? That was a question that didn't occur to me until I looked at what data was given.
So you shifted your question once you knew what was available, and that caused you to create some new.
Well, I knew I couldn't figure out which things were in what watershed. That I knew was out. So I shifted focus.
Well, I went to compute the percent of capacity like we had in the histograms a while ago, and I discovered that Mariposa County Reservoir has an error in its capacity, and that threw everything off.
Mm-hmm.
Yeah.
Yeah, so even though this is the very same data set that was used to construct that visualization we were interacting with, it does not have the same measures as the visualization. So they'll have to reconstruct a measure, and in reconstructing that measure, found error in the data.
Because it's 3,000 to 4,000 times the capacity is what it's got in it.
Exactly.
So we've answered one of our questions already. And then we have Frida, who organized or sort of colored the plots of reservoir levels by elevation. And I think I heard Talia say wow, but I don't know what she was wowing at.
I was just messing around with the data, looking at the median number for capacity, graphing latitude and capacity, elevation and capacity.
Yeah, I mean,
That's interesting.
There's a defense to be made for it. I think you'll run into criticism for sure. It's just like you could do it backwards. And
I calculated the mean capacity, which kind of causes you to lose a lot of information about when it's higher or lower, and that kind of got me to thinking that Dan's suggestion to look at kind of deviance from the mean, or maybe deviance from the volume. It's kind of a next step that I'm curious about. Because when you just plot capacity versus mean volume, it's hard to tell that like one of the axes is shifted just a little bit, and otherwise it looks just like a kind of linear relationship. But just like the axis with the volume on it instead of the capacity is always just a little smaller number than the capacity. But it's not that interesting without maybe calculating like the percentage of the capacity. But then I'm kind of back to the original visualization which just had the percentage of capacity, but I felt like I didn't have a good grasp on how big the reservoir was.
So that's the selection effects are always tricky.
So Cliff, I'm interested in your thoughts. Oh, did I?
But I think looking at those different predictors, there's
So
definitely
first of all, is everyone hearing that over that voice?
That's Josh's background.
Okay. Well, I guess I'm a little frustrated by just what this gives me. I mean, I'm just sort of looking at capacity and drought, but no attributes to sort of ask any bigger questions about. Are there usage changes, or is this just a function of weather? And is it purely predictable by rainfall, or are there some other things going on that might be driving this, like loss of snow cover on the mountains over time? So I guess that's I've been looking for something deeper other than, well, let me understand the reservoirs in California.
A while back, Michelle had a slide up, and you asked, the third question was something like, where else would you go for additional data? And one of the things that I realized was, at this point, I'd really love to talk to somebody who's in charge of a reservoir, and find out what are the other things that are the things that Cliff is talking about. Is there data about how much water they release every day? What are the things that cause them to release more or less water? What are the, all these other questions? And, think about usage. Well, what's the connection between usage and the reservoirs? There certainly must be, but if we talk to somebody at East Bay Mud or the Hetch Hetchy people, they will maybe be able to tell us what kinds of things they consider and what kinds of data they collect, so we'll have a better idea of where we would go to maybe even answer some of these deeper questions. Although I have to admit, just seeing the data for some reason always changes my questions, and I get influenced to be looking at things that I can answer with the data at hand. Sometimes forget my interest in the things that I can't get to.
So I'm hearing three themes that I want to sort of pull out of what we've done so far. One being, well, the questions I had aren't satisfyingly addressed by this particular data set. Or the kinds of questions that would be most interesting to pursue are not addressed by only this data set. Another is, there were several people who had questions that maybe could be addressed within this data set, but immediately started building new measures. So wait a minute, I was interested in percent capacity and that wasn't here, so I had to construct it. Or I was interested in differences in elevation, so I created a class of higher and a class of lower positioned reservoirs so that I could compare it across those two categories. The third is this sort of, I need to know more about what's going on before I can even start thinking about the data I need to address my questions, which is related to these data don't sufficiently address my questions, but is sort of on a bigger level than the data itself. And so we find that this happens all the time when we try to do these kinds of explorations. And we don't think that, when I say these kinds of things, the kinds of questions that students and teachers are interested in are very rarely addressed by a data set that exists out there in the world, because there are all of these interconnecting things. The way that data is collected about reservoirs is different than the way that data is collected about weather, for instance. And so coordinating those two things is difficult, and we would argue is actually a part of data science. It's part of the interesting thing about working with data that we want students to be learning. So we have data sets about snowpack in each of the regions that correspond to these reservoirs. We have information about consumption. We have data sets about rainfall and other weather patterns, so temperature, etc., drought conditions. But they're not in the same format. They don't correspond to these in obvious ways. And part of the work we're doing is thinking through, what does it mean to support kids in, for instance, merging data sets together so that they can answer questions? So Cliff, if we were going to give you snowpack data, what kind of work would you need to do in order to make that useful about relationships between snowpack? And that sort of class of actions, the actions that students take to merge or reduce, so maybe you are overwhelmed by this set of data and decide, you know what, I'm just going to focus on Shasta. If I start to understand what's going on at Shasta, then maybe I can start to make sense of this. So scoping data, changing the scale or focus, merging data so that you have more information, or constructing new measures are the things that we've been thinking about as data moves. And I wanted to do this activity just to argue that data moves, when you're working with these large data sets that exist out there in the world, are a necessary part of data science education. We don't think we should be doing it for students, but we think we should be trying to think through ways to scaffold students to find out how the questions they have can be mapped to the data they have available, and conversely, how they can translate or transform the data they have available to better map to those questions that they might have. And we just decided to throw lots of data at you so that it's obvious it's not a matter of quantity. It's something more basic than that. It's a matter of your question is going to shape the kind of information you need, and the information you have is going to shape the kind of investigation you can pursue. I'm still interested, Cliff, in this question of statistical ideas as it relates to these kinds of time series data. And so we heard some, so I think it was Dan and Joshua talked about these calculations of deviation from the mean. So we still get statistical ideas, but they mean something quite different here, I think, than a lot of statistics investigations. And so I'm curious what your thoughts are on that.
Well, we know from research that students have a fair, they aren't able to look at a time series, a simple time series graph of the sort we're looking at here, and make quick judgments about trends that many novices will just focus on points and where it drops and where it doesn't. So the whole notion of sort of aggregate reasoning applied to this this particular data would be critical. And if a student doesn't have that underpinning kind of view of aggregate and know how to apply it here, then just about all the representations we look at would be there'd be very little amount of data flowing through to the student about time trends.
I was thinking about how you might combine this with modeling to then re-engage with the data. And so if you didn't really account for other factors on water use, different habits and, back to the operators that we heard about, then it would be hard to figure out what this data would mean, because it would just turn into this exercise of let's drag and explore latitude, longitude, elevation, all the things that we already have there, and it's sort of like a test and check to see what you see. If you see something interesting in the trends, initially as sort of kind of building your intuitions, but then going back and pairing it with instruction that says, okay, well let's look at why is it that you have watersheds or reservoirs in the center of the state and towards these regions, and how do, where are our water sources that can move through the water cycle and ones that are kind of fixed. So I just see a lot of opportunity to do some modeling work as well.
I agree, and I think that's part of the reason that we really try to emphasize this, asking the question before you look at the data. What are the patterns that you would expect or that you want to know more about? Because that's sort of bringing out students' initial ideas of what they might want to model. So it's sort of serving two purposes. The first is contextualizing the relationships that are being explored in this modeling way. And the second is identifying whether or not the data that's going to be provided can actually help you or not. So we're really trying to caution against the guess and check, because it's always data in relation to the questions that they're interested in and the patterns that they want to look at.
Right, and I think that was really nice when you mentioned agency as the the frame to look at the problem.
So I feel somewhat differently about that, I guess. I want to become immersed in this data. After all, it's reservoirs. And I don't want to have to think about questions for a while. I just want to get a feel for it all. And then pull back and say, okay, what questions could I answer with these data? What questions are really important to me that I can't answer with these data, et cetera. I guess I'm resisting a bit that I have to go into it with a question.
I think that one response I might have to that, I say I might because I'm making the response, but I don't know how much I believe it yet, is you've been doing this for a while, Bill. And so to you, a trend over time is as real as experiencing the drought. So you're already grounded in this idea that an interesting trend over time is something that then you can put more meaning behind. So the data is almost the same as the question for you because you have so much prior knowledge to sort of hook the data to. I would argue that for students or other people who might not see as much meaning in a trend over time, like Cliff was talking about, they don't understand that this is an aggregate that describes a pattern. Having those questions and the understanding of the system itself provides that grounding that for you is in the trend itself. I don't know if I'm saying this in the best way possible, but
that's exactly what I would have said. That there are scaffolds that you don't need that other people might. In fact, you're presenting internal scaffolds. I mean, people walk up to if I walk up to a painting at a Christie's auction, I'm looking at it very differently than most of the people who are looking at it. You know, they're looking at it in the whole realm of all of the, whatever it was that just sold in that they've seen the Da Vinci's and thinking about the somethings and the whatevers. And I'm saying, oh, cool face, and I need help to sort of know what to look at, be directed to what to notice or what have you, or what not to notice.
I can think of it in terms of when I'm looking at this graph that's up on my screen right now. I already know that cyclical patterns are important. That already is something that has meaning for me. And so I look here and I see something that's cyclical plus, right? It's cyclical plus it has this little dip. And because I understand how to make sense of a trend, and I understand that cyclical patterns are something interesting that suggests a whole set of phenomena that I know about. It might be weather, it might be something else. That can lead to the question. But if students don't have the background knowledge to say, oh wait, I recognize here that there's a cycle, and I recognize here that there's an interruption in the cycle, and so my question is what's going on there? If they don't have that knowledge about the data itself and the structures that data make apparent, then they need to be using other sources to build those questions. And I would argue that thinking about drought itself and weather itself are those sources.
I see, okay.
Yeah, so it's sort of where does the meaning live? And how does that drive the kinds of questions you can ask? And for you, the meaning already lives in the graph in a way that for the students it might not.
Well, and the question I'd ask Bill, just to think about the role of questions, is when you decide to make a particular graph, there's got to be some, you're not just making a graph by grabbing two arbitrary attributes. There's at least the beginning of a question or a query when you begin to focus on it, even though you're trying. I think what you're saying is you've got an overall goal to kind of really see what's going on here before you focus too heavily. But when you make each move, it's got to be directed by some question.
probably the curse of knowledge, right? You know that there are questions to be asked in almost every single one. So my guess is that in part, you might be scanning the list of all possible questions to try to find the more interesting possible questions. Maybe that's a step too far, but.
So you're saying, Michelle, that to scaffold coming to an understanding of the data, students should think about the context and come up with some questions before looking at the data.
Yeah, I would argue that for two reasons. One being to scaffold this meaning making, but the second to think about the structure of the data itself. So if I come up with a question and then think about what kind of data I would need to answer that question, if then I look at my data set and the data isn't there in the way that I needed, I think I'd be more likely to think about how I might transform this into what I need if I'd thought about it ahead of time, rather than just being given a data set and pursuing a question. So to say it another way, I think data moves happen when you know that you need the data to be in a different form. And one way to think about what form you need the data to be in is to think about the questions that you want to answer. So
whenever we look at a data set, some visualization,
mm-hmm.
the overriding question is, what is going on here?
Mm-hmm.
And that always seems to drive where I go next.
Mm-hmm.
What is this point doing way the hell out of there? And, you know, the outliers thing that drives us.
Mm-hmm.
And then the patterns and the colors. You're suggesting that the question of, I don't know, what's a typical, maybe I need to know what a typical question I would go into, you would see students going into this with, would be.
One that we've seen already, and we've done this a few times, is, I think, was this Sherry, around regional differences. So what is going on in the north side of the state versus the south side of the state? Is it drier in the south side of the state, or are reservoir levels lower in the south side of the state? So as soon as I ask that question, and then I take a look at this data set, I think to myself, I need a way to split these up into north and south. Otherwise, I can't answer my question. And so it might be that I split these up into north and south by doing some kind of classification or categorization of latitude into this is a member of the north group versus the south group. Or it might be that I just use latitude as one of my variables. But I think thinking deeply about what is it that I need to do to this attribute to get it to do work for me is linked to the kinds of questions that people would ask. Whereas for you, what is going on over time, because you work with data quite often, might be enough. And then you see what's going on over time and you know what an anomaly looks like. So what is going on with this dip? Because I know that these kinds of dips in a cycle suggest something wacky. Or what is going on over here with this noise? Something different is happening here than the rest of the region.
So let me ask this one then, and maybe you've answered this already and I've lost it, but let me. So looking at your graph where you have the top one, presumably that's Lake Shasta highlighted.
Mm-hmm.
What about the situation where a kid sees that graph and says, I wonder why it goes up and down so much, and then they have to find out about, they have to remember about weather patterns and things like that?
So we do have that happen, but this is how that happens. We say, what do you remember about the drought? And the students would say something like, well, there were a few years when it was really dry and we all had to stop using so much water.
Mm-hmm.
And so that would predict a pattern that is relatively high here and then goes down and then comes back up after the rains. So they predicted a pattern that's different from the pattern they have here, which
Right.
might lead to the question, wait a minute, why is it going up and down more than I expected?
Mm-hmm.
So there, I think the question is still born out of their prior expectations. It does, in this case, also involve some of the data. So I have to make a prediction. I have to say something like, what was the pattern of the reservoir and does it correspond to my memory? But then I might notice that it doesn't because there are these little ups and downs, and that doesn't make sense given what I already know. So what might those little ups and downs be related to? So I think it's a back and forth, but I think it's still grounded in their understanding of the context and whether that's represented in or how it's not represented in the data that they're looking at.
So I guess I like the idea that you're bringing the context in immediately through thinking of questions without looking at the data,
Mm-hmm.
and that might keep learners focused on meaningful patterns as opposed to not so meaningful patterns that they see in visualizations. But here's a question. When you've done this, do you have that graph up there to start with when
No.
they see the data?
No.
Uh-huh.
No, so I started this with you all because I knew that you were likely to start computing new attributes right away and was interested in where it would go.
Uh-huh.
With students, often we would start with the reservoir that's closest to where they live and say, what pattern would you, what would you expect this to look like? What are questions you have about what happened here in our region?
Uh-huh.
And then use that as a spring point for these deeper questions. So you could imagine a pattern that goes, what would you expect the reservoirs to look like? Then they recognize that that's not actually what the reservoirs looked like because there are these perturbations. What could have caused these perturbations? That leads to questions about things that Cliff was identifying. So, well, it looks like it might be related to weather because it happens once a year that it goes up and down. Did it rain? Is it related to snow? Were people using more water in the summer than the winter? So then that starts to lead to these questions that require manipulations of data.
Michelle, can I jump in with a thought on this? You seem to be talking about the agency part of this the three parts of this model that you gave us, which I really like. And I'm wondering if the other two parts are kind of at the intersection of what is impossible and what is hard. In that, so a lot of these like intuitions that kids might bring or the context they bring with them about a question, about a phenomenon, it might seem to them impossible to get data on some of those, on that information. Whereas to others, that might seem like a simple SQL query or a simple merge, right?
Mm-hmm.
And so you mentioned that that we would get, that this had all of the data, but some of that data is not here, like about the drought status or about the rainfall.
Mm-hmm.
And I'm wondering about how to think about, like, if the student does raise the question about, hey, I remember it was raining a lot, back in 2015, or whenever it was. Would they perform that merge? Should they? How would they access that data? So I'm thinking back to your framework. How would they access that data?
Mm-hmm.
What tools would they use? And I'm wondering if that can kind of almost separate this question of the agency as the question in the context they bring from how they go about doing it, which is something more technical people can do trivially, but it can also be really hard to join a data set, even for experts sometimes.
I agree, and I don't think that the difficulty in joining data sets is merely technical. I think it's often conceptual too. So, and what we've been trying to do is scaffold the conceptual part of that and maybe postpone the technical part until the conceptual part is there. So let me try and come up with an example. We have students write the questions that they have. We tell them that we have this data set. They explore and refine their questions based on the data that's here, not the whole set, but we give them a subset of this data that's appropriate for the questions they ask. And then we say, what is other data you might need? So this gets into the access. If you could have data that is better suited to answer your questions, what would it look like? And they tell us what it would look like, and then we give them what we have, which does not always look like what they need. We get it into the closest form that we can to what they have, but we try to make it clear that, look, this is the best we can do. It's not exactly the data you need, but let's think about how we can put these two things together to answer your question. And so the conceptual challenges around that might be something like, I have weather data by county, but I don't have latitude and longitude, so how do I need to make that merge, for instance? And it often moves to lots of data reduction. Okay, let's just look at one reservoir and the closest weather patterns to that reservoir, for example. But I'd argue that that's part of what it means to be doing this merging, the conceptual work of this merging. The technical work around how do you do a join or a SQL query, we're not really looking at. Instead, we're looking at these conceptual issues of, I have access to some data, I don't know exactly what it's going to look like, but what should it look like and how close can I get? The tools for us are around the transformations of the data we have. So we're not asking students to go out and find their own data sets and reformat them. We do a lot of that work, but the structure of the data we keep the same. And so the tools really come in with respect to visualizing, constructing new measures, maybe actually doing the merge so that they have their own data set, but it's not at the level of SQL queries or anything like that yet.
Thanks, Michelle. That's super helpful. And I guess I'm wondering if is this data good enough question is kind of what Bill is pointing out about sometimes the question does come from the data, and it does. Sometimes, oh my gosh, there's all this data on weather that comes from personal fitness trackers. I don't know, from people's temperature and their activities. Like I didn't know I could use that to ask a question about temperature changes on these different ridges and mountains or something. But it's still, well, yeah, enough said. Thank you for your answer. It's helpful.
Oh, no problem.
And thanks, Bill, for raising this issue.
And I agree that there are insights and questions that can come directly from the data, but as Cliff noted, I think without any understanding or experience with what you should expect from data or what constitutes a surprising result or pattern, there isn't much to get started. And so for Bill, this cycle has a messy bit at the end and a dip right here, and that's interesting because I know cycles shouldn't look like that, is enough to raise a whole number of questions that for students, working backwards and saying, wait a minute, I know what this dip here is. This dip here is the drought. But why are these ups and downs? Oh, wait a minute, it's weather. So sort of working backwards from the context rather than working directly from these are patterns that I would not expect in clean or perfect data is what gets them started.
But by the way, just looking at Shasta, I noticed something here, that if you look at the slopes of sort of that post-winter slope heading down on the first three cycles, they're about the same angle down. And then when it gets lower, you can see that flatten out a bit, which you would guess are the restrictions they're putting in place on usage. And then they get steep again once it gets high. So suddenly, boy, is that going on everywhere? And
yeah, one of the first things I spent my time making was some kind of a derivative of normalized change. I got as far as doing maximum normalized change and seeing which were the ones that were maximum, but I hadn't gotten farther than that. That was one of my questions.
And I think that's another example where you know that measures of change exist and that those tell you something interesting. But if you hadn't known that, then the only way to get there is by thinking, well, how much hotter is it this month than last month? Or starting with the things the change is about instead of change as the goal.
So you were computing derivatives literally? triangle?
Well, I was computing next minus current divided by, or next minus current and then normalizing. Wasn't lit. I mean, I guess that's a derivative, sort of.
Yeah.
Yeah.
Because the
Delta.
X differences are constant.
Yeah.
Difference. Yeah.
Took me a while to figure out how to use lookups, but so there's the technical piece as well. Even when you want to answer a question, one of the things that I'm intrigued by in this is going from the other side of the question of the sort of what is in that thinking that Bill or somebody who takes this in holistically, what's involved there. And there's a whole, I was looking into visual thinking strategies, other kinds of things people use in art, for example, where they leverage people from low level, if you want to call it that, interpretation to sort of more sophisticated viewing of things like art. And I'm wondering if there are strategies or questions involved in helping students think through the process of exploring the data set themselves. How do questions arise from data? What are the kinds of things that you ask? And there are some nice, there's some controversy about what the research is that supports them, but some nice simplified sets of questions people use to direct thinking around visual artifacts in other domains that might be leverageable in some way here, because part of that is an interesting question. Basically just saying, what do you notice? What questions does that raise? What more data would we need? Those are the kinds of questions we're asking overall here, and it feels as if there's some scaffolding for students in that interpretation exploration that needs to happen, because ideally we want them to get closer to familiar.
I wonder if media literacy
Right,
folks might, like, who is this trustworthy? Who collected it? For what purpose? What was their aim? What message were they trying to convey? Messages.
Yeah, we do a lot of that with the visualization component. So before coming here, when looking at visualizations, we ask, what story is this trying to tell? What do you think the point of this is? And I mean, you all noticed an error. The students noticed that error too. So how trustworthy are the data if one of these bars isn't moving at all, for instance? Okay, so I'm gonna move to the second example, which I think will go a little more quickly, but my goal with this one was to think about these data structures and merging and doing the things you need to do to data to answer this diversity of questions that arise anytime you're working with relevant, interesting data sets. And so I think we accomplished that goal, so thank you. The second one is gonna focus on something a little bit different. So am I gonna close this? I'm not gonna close this because I want to have access to the original document. Okay. And so now we're going to move on to, and sorry, here's the last set of questions, which we all discussed anyway, but how were the data that I provided different from what you need? So Cliff, that was what you sort of stated, that they weren't what you needed. At least they didn't help you answer anything interesting. How could you refine your question to make these data more useful? So several people talked about changing their question based on what they had. And then how can you manipulate, reorganize, or supplement these data to make them more useful? So those are really the questions we're interested in when we think about working with data in these ways. So the second activity is a little bit different. I'm going to start with a puzzle. And many people are already familiar with this story. Even if you're familiar with this story, I think this will be interesting. So please don't roll your eyes. Here's the puzzle. In 1995, gray wolves were reintroduced to Yellowstone National Park after nearly 70 years. In the decades since then, there have been a number of changes within the park ecosystem, including that the rivers have gradually changed their course to form a more meandering pathway. Can this be explained by the reintroduction of just a single species? And if so, how? So before we dig in, I'm going to provide some helpful information here. These are photos from a research paper showing one region of Yellowstone Park in 1924. So this was when the wolves had been hunted away. 1949, 1961, and 2003. Just give you some time to look at that. And you'll notice this is a river right here that became almost non-existent over here. And so my questions are, what conjectures or questions do you have about what happened here? Again, what data would you need to investigate that, and how would you collect and organize that data?
Well, I want to start with some basics. What do the wolves eat?
Mm-hmm.
What other changes are there besides the wolves? I mean, we saw trees growing. They might have more to do with rivers than the wolves.
Oh, yeah, so I'll go back here. Here you go. There are more trees, at least in the picture.
Mm-hmm.
I don't know if there are more, they're bigger.
Yeah.
So we have questions around both the quantity and size of trees, it sounds like.
Mm-hmm. It's interesting. You said that the 2003 river was almost absent, and I can't quite tell that from seeing the picture, but it does bring up a question of, well, is there a difference in the total river flow? They might have gauge stations that measure how much water is flowing.
It looks like a road was built between
Yeah.
24 and 49. So
Yeah.
one wonders then about traffic through and roads built through there that could co-vary with wolf introduction.
Okay, and I'm going to give you a little bit more helpful information here.
Yeah, I need to get glasses.
Oh yeah, sorry. I think I can make this bigger. There we go. And the y-axis, or sorry, x-axis is shared here, so 2010 is the same vertically.
Well, beavers, they make a difference.
Yes. So these are not the same years as the years you saw. So this was before the reintroduction of wolves. These graphs are after the reintroduction of wolves. So starting at 1990, they were reintroduced in 95. So does anyone want to venture a guess what's happening?
Those of us who know the story should probably not talk.
Yeah, at least not yet.
Well, naively, wolves might eat elk, and there's maybe some interaction between beavers and cottonwoods, but I'm trying to remember when I last saw this data what we discovered, but I can't remember everything. So
Apparently wolves don't eat beaver.
As far as I can tell, no.
maybe there'd be a lot more beaver if there had been wolves, but yes. Beavers react to the newly meandering rivers.
Maybe the beavers make the rivers.
Yeah, yeah.
Okay, so it sounds like people are starting to stitch together some possible explanations. Now, normally we'd spend a lot more time trying to tease out what could be going on, but I'm going to go ahead and connect you to some data. So now you'll see this bit.ly link. It's capital Y, S, capital W for wolves.
We'll go down into
And you'll see the details about data are sort of ill-formatted because of the text box. But if you need any more information about any of these attributes, let me know.
Okay.
And if it's not in this document, just ask me. And you'll notice that we have, again, you don't always get the data you want. So we have incomplete information here. So for those of you who have some idea of what could be going on but have not heard this story, see if you can use these data to help you stitch together a possible explanation. Those of you who have heard the story, see if you can find any alternative explanations. And what we'll do is, I'm going to go to the document here. I'm going to go to the bottom of the document. Oh, these are great. I'm going to save all of these screenshots. And because we have so many possible relationships that could be going on, I'm going to ask everyone to share their more notable findings at the end of the document here. So I'm going to call it Yellowstone findings. And Cliff, I'll point out that we have, in your case, your data wish came true, and we have both tree counts and also some data on tree size.
Okay, let's see.
I must say I've never had attribute descriptions that have taken me as long to try and wrap my head around.
I finally figured out that the O's are additional description.
Yeah, that's formatted. It's a Word document that I had to copy paste in here. So
makes perfect sense.
Wow, I never knew that grizzly bears might be relevant too.
Yes, and the estimates are based on the number of mothers and cub scientists. No, that's not what they mean.
Wait, what?
Oh, mothers and cubs. Okay, but I read it first as cub scientists, what they found. Because you know that the average grizzly family produces 2 scientists in addition to all of them.
Counting cub scientists is a better prediction of total number of grizzlies than only just any cub.
And Bill, the data cards option, is that available in this document?
No, not yet.
This is a good time when you'd want it.
Yeah, really. Wow.
So we're going to get like this Owens Aspen thing. We have plotted on the same.
Tim, I can't hear what you're
No,
saying.
I'm sorry. I'm just muttering. So now I'm losing track of what our instructions are for what the major question is, as opposed to the questions that we might be developing based on the data. Because I know I'm not supposed to do that anymore, but.
All you're supposed to be doing this time is trying to come up with an explanation for what might have happened.
But the what is the change in the streams?
Yes, correct. Which just so happened to happen after the wolf reintroduction.
Okay,
Could it
so
be that the wolves affected the paths of the streams?
So wolves are going up, elk are going down, all kinds of trees are going up, which makes me wonder, do the elk eat the trees?
Okay, so we have wolves are going up, elk are going down,
trees are going up.
Trees are going up.
Is there some way that additional trees, I mean, I picture, I don't know, roots making it harder for streams to erode things, and so they have to go directions and become windier, but I have no idea whether that's geologically makes any sense.
Okay. Anyone else have ideas or relationships they found that they'd like to throw out there?
Well, the bison went way up too. So an alternative explanation would be that the bison are doing something, tromping around in the streams.
They're tromping in the streams.
Diverting them, causing meanders.
Yeah, but the beavers are going up, and they definitely influence streams.
Grizzly bears seem to be increasing as well.
Increasing.
Talia, you said it was, what was that?
Grizzly bears.
Okay. Okay, and Tim, you noticed the beavers? Bill, you noticed? I'm just trying to keep track of all of it. So far we've got wolves are going up, elk are going down, trees are going up, bison went up, beavers are going up, and grizzly bears are going up.
What causes streams to meander anyway?
Mm-hmm. Good question.
I thought it was like
Silt.
elevation.
Right? No, okay.
I mean, steeper slopes less meander.
Yes.
But the slope hasn't changed, or we don't know.
We don't know. But I mean,
and one detail that someone asked about earlier was if there was a change in the amount of water coming into the park. And I just so happen to know that the water coming into the park via rivers and streams is regulated. So it's not that there's some river out there dumping or sort of changing dramatically in how much.
however, there is two giant years of rainfall in 2003 and 2004 compared to all the other years. And I don't know whether that could have flooded something. Make more silt. Silt maybe makes you meander. So that's an alternative.
Silt comes from erosion.
Yeah. So here's a picture that might, so 2003, 2004, giant rainstorms, more than 10 times as much rainfall as usual, it looks like. And so mud and silt washes into the already relatively flat river basin. The rivers make meanders because of the silt, completely independent of beavers and wolves.
Certainly an alternative explanation.
Do you need a power cord? There's one on the floor here. Oh, it's probably the wrong shape. Okay.
Wow.
Oh, what was that?
That was just thinking about all these attributes.
Yeah. So
now, when beavers create a dam, it can cause an existing river to overflow, right, and take another path.
Right. So that's a good thing for the beavers going up, being connected to that.
So I don't think we're going to come to a conclusion in 3 minutes.
I don't think so. We have 3 minutes left. So instead, I'll just pull out some of the themes of what just happened here. People started identifying different relationships, but there are too many relationships here for everybody to investigate all of them. Instead, people started pursuing specific relationships based on their conjectures, based on things that they just happened to notice, and started trying to build stories that stitched these relationships together. So I noticed that trees are going up. It might be that they're growing roots to prevent erosion. I noticed that the beavers are going up. I think this was Tim noticed the beavers were going up, and then Cliff contributed that when beavers create a dam, this can reroute the rivers. So this is another approach we've been taking, is having students explore subsets of data that all stitch together to form explanations through these stories that students could be telling. We have 2 minutes left, so I'll tell you the sort of traditional story that's told about what's happening here, and then it turns out it's an unresolved problem. So the sort of familiar narrative is that the reintroduction of wolves did cause the rivers to change their paths because they ate the elk, so they ate some of the elk, but also pushed the elk away from the valleys where the rivers were. So that allowed the trees in the valleys specifically to grow taller and healthier than they otherwise would. Browsing is when elk eat the leaves off of the trees. Beavers can only construct dams with trees at a certain height. So there were very, very tall trees before, or there were very, very small trees that were eaten by the elk, but there weren't trees at this level of maturity needed for beavers to create dams. When the elk had been eaten and scared away from this area, the trees grew to the appropriate size, allowing the beavers to build the dams. The roots also stabilized and sort of reinforced in the soil, causing these streams to change patterns in unpredictable ways. And so that's sort of the story that's told, and it was this big internet phenomenon meme that went around. It turns out that now scientists are challenging that narrative because grizzlies are another factor that wasn't considered. For one, there were these strange fluctuations in the weather and specifically rainfall amounts. It turns out elk aren't all that afraid of wolves. They're kind of mean. Wolves will go after baby elk and hurt elk, but they generally don't hunt elk troops. So this is an ongoing sort of question, and as you can see, there are many conflicting explanations that emerge through the data that suggest it's a more complex system than one might expect. And so this is another thing that we've been looking at, is how do we tell these different stories with and through data in ways that allow students to come together and piece together what might be happening in a system. Again, I threw it all at you at once. That's not how we go about it when working with students, but you can see how this can build a pretty rich exploration over the course of days and weeks.
And should we throw out the various curricula that have been developed around this story?
That's a good question. So when I talk to teachers, they'll often say that they tell this story, but they don't use, it's sort of a nice example of a trophic cascade, and so it's left at this illustrative level. And so they're very excited about the prospect of using data to explore it more deeply. I'd argue that the current standards want us to complicate these kinds of stories and really start thinking deeply about how much do we know depending on the evidence we're looking at. And so I don't think we should throw them out, but I have no problem complicating them.
Well, what a great experience, Michelle.
I hope so. It was a lot of stuff, so thanks for hanging in there.
Yeah, good. So any parting words, Talia?
Well, I just want to make sure Michelle had a chance to give us any parting shots or anything before I ended.
Oh, I think I'm good. I'm happy to answer any questions people have. Feel free to email me, share any materials, etc.
Okay. All right. Well, in that case, let's go ahead and finish on that note. Thank you, Michelle. This was really, really phenomenal, and I really appreciate the time you took to prepare all these CODAP documents and all these materials for this webinar. I thought that it was wonderful, and I had a terrific time, so thank you very much. Thank you, everybody, also for joining us today and participating. You've been a great group. If we did not get to your question, or you'd like to leave additional questions in the Google Doc we shared, or go ahead and do so, and we'll leave you an answer either in Google Doc or an email. We also had a lot of great interaction. I'm grateful to all of you for making such rich discussion happen. We will be sending a link to record a session briefly. And if you enjoyed this webinar and you'd like to attend future data science education webinars, we'll be taking a break in December, but we will be starting again in January. Details will follow shortly about that. You can sign up for future webinars at concord.org/meetup. You can also stay connected with us on Twitter at CODAPDataSci. Use the hashtag DataSciEd to tweet us any additional questions or resources, and we will respond to you. Please feel free to visit our website, codap.concord.org, to connect with us as well. Everybody have a great afternoon, and thank you very much.
Bye.
Bye.
Hey.
Thank you.
Thanks all.
Bye.